Hi everyone, today I'd like to talk about PythonNet. If you're thinking about integrating Python with a .NET application, this library is going to help you do it. I'll briefly talk about the benefits of Python and why you might want Python in your .NET application to begin with. Most of you will want it because you want to use libraries from Python such as NumPy or Matplotlib. Then we'll go into the currently two most popular options for integrating Python into .NET, which are PythonNet and IronPython. And then we'll go into setup of PythonNet, followed by a simple WPF application with PythonNet integrated. And then we'll talk about Matplotlib. And it's going to take some .NET data from our WPF example and then plot it. So I'm not going to spend too much time talking about the benefits of Python, since you're watching this video already, so you might already be familiar with most of these, and as you know that Python does have a rich set of numerical and machine learning libraries, and that just makes it easy to work with and allows you to do rapid prototyping. So the differences between PythonNet and IronPython. The two have just two different approaches to interact with Python. PythonNet needs an existing installation of Python on your machine, and instead IronPython is an actual implementation of the Python language. But the two have big differences when it comes to features that they support. So with PythonNet, you have the capability of using almost the latest and greatest version of Python. IronPython instead is stuck at version 2.79. There are works to upgrade it, but that's going to take some time. With PythonNet, you can use pip or conda, for example, to download NumPy library or SciPy library, and you have the big benefits of using all those libraries. But they're both easy to use, so if you really want the capability of using these libraries and the latest and greatest from Python, which more than likely you are, then PythonNet is really your only option in this case. So, as I mentioned earlier, you do need a Python installation on your machine for PythonNet to work. Let's see, I'm going to choose add Python to the path. You can opt not to do that, but for me it just makes some things easier. And I'm going to do a bit of a custom installation just to make sure that all these checkboxes are ticked, especially this one, because this is how Matplotlib actually plots things to the screen, and this is the library that it uses to do that. And then once that's checked, and just check these boxes as well. Let's see, if you want the debug binaries for Visual Studio, you should check these boxes. For now, I don't need them, but you can debug Python as well with Visual Studio. And there we go, we are ready to install. So the next step would be to install PythonNet. I'm going to install it from source because I find that the NuGet versions of it are just a bit outdated for my taste. So let's do that. Let's clone it. And actually, I have already cloned it. And once you have cloned it, I am using Visual Studio 2019, so I'm just going to open up this solution. Once I do that, the projects are on the left, but before that, I'm just going to make sure that I have selected release WinPy 3. And also, I want to make sure that the project properties are targeting the correct version of Python. So if you notice earlier, I installed Python 3.7. I'll make sure that that's selected, save, and Control-Shift-B to build. So there we go. Everything builds. Let's check the binary directory. In PythonNet, you'll see that there's a bin folder now, and there's the python.runtime.dll, and that's what you'll need. So there's one more thing we need to do. If you open up this runtime.cs, you may notice that there is a flag called Windows. And the reason that's important is because it says DLL base, and it's appending the minor version to the path. Now for you, it may not be set. I had to set it for my build to work. Well, actually the build did succeed, but I got runtime errors when trying to load the DLL. And the reason for that is if Windows is not there, then it's going to say Python dot and then the minor version. And for me, it really needs
Python, but without the .minor version, because this is the Python DLL. As you can see, this is just Python 37.dll. If that flag is not set, it's just not going to find the right DLL. So I didn't have to do that in the past, but I just noticed that I have to do it now. So if you just find yourself that you're stuck and then the DLL is not loading for some reason, that's probably the cause. And the other cause might be that your project is also set up with any CPU, and what you actually need is x64. So just be careful there.
Now, before we get into a coding example, I want to talk about structuring. How you structure your application, it's totally up to you. What I'm about to show you is how I dealt with it in the past and what has worked best for me. For this particular example, it's very simple. It has two layers, a presentation and an application. In your situation, you might have a domain layer and it might be a little bit more complicated. But yeah, so let's get into these two components I want to highlight. The Python engine is the component that we're going to build that's going to sit between our application and the PythonNet library. It's going to allow us to run simple execute commands and query the Python engine for variables. And the other thing is the Python API. So now what you may have is users who are used to programming in Python, but our .NET objects are in capital letters and they have different calling conventions, etc. And we want to unify the two by providing this layer. And when the user actually wants to use our objects, they're going to go through this layer, and it's going to make it easy on them because this layer, it has the responsibility of making things Pythonic, and you'll see in a bit what I mean by that. So without further delay, let's look at a coding example.
So now I want to show you some coding example, and the best way to learn something is just by doing it yourself. So this is what I've built. It's a snake hospital, and let me just give you an idea of what that looks like. There it is, Cobb Memorial Hospital, one of a kind, unique snake hospital. We have here our patient name, their age, whether they're insured or not, and the ID. The ID is kind of long, but that's because they're snakes. Now, let's open a script. Now, what I'm trying to do here is just simply use Python to create a histogram of the patient's age. So let's open it. And if you guessed it, there we go. It's a histogram of our patient's age. And this is all done by Python, and this is the script behind you. And let me just make that a little bit bigger so you can see it. So it's using Matplotlib, the hospital API, and then from there it's getting its age, putting it all in a list, and then from there it's plotting everything with Matplotlib with 20 bins and with green bars. Furthermore, here's the X label, the Y label is the frequency, and here we have our title. So in the larger picture, what's going on here? So let's go back to the application. Here we see all this information. Well, where do I get it from? Well, actually, all of that is just simply hard-coded. So here it is. It's nothing fancy. I simply just hard-coded all the patients, and I have a patient service, which I'm using in Python to simply get all the patients. Now, the reason why I want to do that, and I didn't want to actually go to a database and query for patients because I'm just trying to show you what a Python API would look like. In your case, you can probably structure this differently, but if you have domain objects like, for example, patients or anything else, you kind of want to build a Python interface wrapper around it, and that's what the API is. And let's go to the patients.py file so you know what it is. It's simply a class that uses that service that I was talking about to simply get the patients. Now that's all good and well, but what's the big picture here? What's happening when I executed that script? Well, the first thing that happened is actually there was this initializer Python file. After that was ran, the init.py file was ran, and that belongs to the module. And after that was ran, the patient's age histogram was ran. So let's go through each one of these and see what they do. For the initializer, I have something very simple. And if I just go to, let's see, initializer startup. this is the initializer. Here's what it's doing. It's basically importing built-ins and setting the patient service to the patient service variable that I created in the built-ins. How do I get this? I have this DI container to resolve any type that I want from my C# application. You might be able to do this differently, but I found this to be a straightforward, proven way. So here's the full name. And what is this DI container? Well, let's check this one out. So remember the interface to the PythonNet that I was talking about earlier, this guy, the Python engine. Let's go and check that out. And if I go to the PythonNet, here we go, it just has the IPython engine implementation. And here's the interface. It simply takes a command and outputs the value from the interpreter. And this is just the simple execution. For setting variables, it takes a name and a value to set the variable to, and all of this is done to the Python's current scope. Here's a list of search paths, which is where Python looks for modules. And here, if you want to set a search path, you have to do it through this method. And here's the initializer. Now, the initializer is this part. Here's the initializer. This is the thing that's run. It's a script. So if I go to the implementation of that, I see that I have a DI container that I'm setting a variable to, and here's a DI container. So it's basically a class that I made for myself, and it takes an I container. Now, I have to pause a bit and explain, if you don't already know what dependency injection is. If you do know it, then this is easy to understand. If you don't know it, it's a little bit difficult to comprehend. But the best way I can explain dependency injection and how that works is that you have this container class, which has all the objects that you're going to need for a specific purpose. So this container contains objects that I'm interested in, and in particular, it's one of those services that you've seen earlier. So what I do in this case is I take this container and I store it for later use, because I'm going to use that container to resolve my types. And it has a resolve type here, and this resolve is the actual method that Python calls. And it calls it with a full name, and then I do some reflection magic to get all the types in the assembly, and then I check for the one that matches the name. That's pretty much what it does. And after that, I set the DI container so I can use the DI container anywhere. And I use the, let's see, it's the startup.py. When I resolve the DI container, I do it this way. It's already in Python memory, so I can just simply call DI resolve and then resolve. And then here's my service. Furthermore, after that, I have the variable set, and then the next thing I want is to execute this startup script. And that startup script is simply called startup.py, and it's simply here that you've already seen. So in this case, I want to set this first before I execute this script, or else it would just fail. And let's see. So here's a bunch of code, and I think explaining all of this will take some time, probably several videos. So if you're interested in seeing how all this works, or if you want me to talk more about this more in depth, I probably can devote some time to make videos dedicated on just the engine. Or if you also care about how the GUI is implemented, it's not, I didn't put too much time on it, but if you really want to know more about it, I can also talk about that. It's using some reactive UI components and bindings. So yeah, and I'm going to stop it here because I forgot to dispose it. Very important. Dispose with. I'm going to say dispose of both. There we go. And yeah, depends on what you guys want. Making videos does take a long time. So I'm going to upload this to GitHub so you can take a look at it. And I can also just make videos on these components. So yeah, thanks. So that's the end of this video. So I might have gone through the examples a bit too quick. And if you want more details, if you want me to make another video, yeah, just let me know. It does take a long time, so depending on how many people request it, I'll put the time to make another video. But yeah, thanks for watching, and I look forward to seeing your comment down there.